recording, we were talking about the basic idea behind a line of reflection and how this is the same distance as this is. And how if we have a vertical line of reflection, that means if it's on the left 1 unit from the line, then it's going to be on the right 1 unit from the line. If it started out 3 units to the right, then it will be 3 units to the left. Same thing happens if we have a horizontal line. This is a horizontal line. Okay, except it's above and below. If it starts out above the line, it's going to end up below the line, and however far above it was, 3 in this case, it's going to be 3 below. Point B over here, it started out 1, 2, 3, 4, 5, 6 below the line. So it's going to be 6 above the line. Okay, so vertical lines and horizontal lines, the most convenient way, the reason they help us so much is because when we're doing reflections, very often we want to go across the x-axis or the y-axis. So here's the x-axis, and this is 2 different points I'm reflecting across the x-axis. They've already been done. Let's just go ahead and do some. Let's say that I'm reflecting across the x-axis. That's this one. And let's suppose my point was at 2, 3. Okay, one thing to remember about coordinates is those 2 numbers are giving me directions. They're telling me go 2 to the right and 3 up. Well, if I'm going over the x-axis, then I'm going to be moving up and down only. I'm not going to be moving to the left and right at all. I'm going up and down. When you go up and down, the only thing that changes is the y, because y is like your height. So if I'm 3 above the x-axis, I'm going to now be 3 below. The x value does not change. But this is not a positive 3 anymore. Now it's a negative 3. So the only thing that changed was the sign of the y. Okay, let's look at another one like that. Let's say you have the point negative 1, 5. Okay, if it's going to move across the x-axis, that means it'll go down here somewhere. So we have to say, okay, it's 5 above. Well, that's this number right here. So now it's going to be 5 below, and that's also going to come up in the y-coordinate, because the y-coordinate, remember, negative 1, 5 means I go left 1 and up 5. So if I'm going to go 1, 2, 3, 4, 5 below, that means I go left 1 and down 5. So the only thing that changed was the y value, not the x value, because I'm just going up and down. And the thing that changed about it is just its sign. That's always going to be true when you reflect over the x-axis. When you reflect over the x-axis, the only thing that changes is the sign of y. So we're going to keep track of some rules here. Across the x-axis, the way we write that is we say this was our original point, and this is our new point. The only difference is I have a negative in front of y. Now you got to be careful, because that doesn't mean y is going to be negative. Sometimes it was negative to start with, and then it ends up going positive. This really just means the opposite. So whatever the y value was to begin with, the new y value has the opposite sign. Okay, let's look at reflecting across the y-axis. All right, new piece of paper, boom. Across the y-axis, let's suppose, now the y-axis is right here. It's a vertical line. Y-axis. Okay, so if I am on the right-hand side of the y-axis, like at this point, 3, 2, the 3 is telling me how far to the right I am. It's telling me 1, 2, 3 units to the right of the y-axis. So I'm going to go 1, 2, 3 units to the left of the y-axis, and that will be at the point negative 3, 2. Couple of things to notice there. The y value didn't change. If you're going across a vertical line, which is what this is, my pen is a vertical line. If you're going across a vertical line, that means you're moving left and right. Here's the vertical line, you're going left and right. So you're only changing your x if you're going across a vertical line. So the x is the only thing that's changing. It's going to have the same number value because you're still the same distance away from the line. You're still 3 units away. The difference is which side. So positive 3 versus negative 3. Let's look at, excuse me, the 1 point. Let's go with the point -1, -5. It is currently 1 unit to the left of the line, and so it's going to end up 1 unit to the right of the line, which puts it at 1, -5. So again, the height did not change because we're going across a vertical line. The only thing that changed was the x. And the only thing about the x that changed, it's not just the x changes, it's specifically the sign of x changes. Okay? So the only thing that changes is the sign of my x value. And I can write that as a rule by saying whatever your original point is, the new point is going to be the same thing, but with a different sign on the x. And that's what that means. Okay, so let's practice a couple of those. If I want to reflect, let's just, that's not a good piece of paper. Let's say I want to reflect this. Reflect the point -1, 6 across the x-axis. Okay, so I go up here, and this tells me all I have to change is the sign of the y, right? So I'm going to take that, and my new answer is going to be -1, -6. All right, let's do another couple. Let's say so you don't even have to see them if you know the rule. You don't have to see the graph and think about where the points are. But you can, if that helps you, you can draw it. Okay, when we go across the y-axis, the only thing that changes is the sign of x. So that means I'm going to take this x value and I'm going to make it positive. And that's my answer. Okay? All right, moving along, we have other lines we can reflect across as well. Some of the weirder ones are these like perfect diagonal looking lines. These are lines that a lot of times people forget what they look like. So let me just take you real quick. Got to figure out where I'm going. It's like 15 clicks just to get this. There we go. Okay, I'm taking you to Desmos. And if you want to, you could play around on this on your own. If you ever are asked to reflect across a line and you're like, I don't remember what that line looks like, you can go to desmos.com and you could type it in. So here's a line that we're going to examine. The line y equals x. Okay, what it is, you can see it there. It's like a perfect diagonal that goes right through the corners of all the boxes. And it's got a positive slope because lines with a positive slope go up from left to right. So if it's going up from left to right, that's a positive slope. So this is y equals +1 times x. One way you could think about that is, remember y equals mx plus b? What's happening here is it's like the m is 1 and the b is 0 because it goes through the origin. Remember, the b stands for where it crosses the y-axis. So the y-intercept is at 0, 0 because it crosses right at the origin. Okay, so basically what I have done here, y equals 1 times x plus 0 is exactly the same as just saying y equals x. That's that line. So we're going to reflect across that line. The other line we're going to reflect across is y equals -x. Y equals -x is like if the slope is a negative. So it's like a perfect diagonal that's negative. There it is. Okay, the black line here, which is this one right here, that's the y equals +x. Negative slope falls from left to right. So the blue line here, like this, that's y equals -x. So if I change this to say -x, you'll see it lines up. Okay, so let's go back here. And if I have to draw the line y equals negative, excuse me, y equals positive x, I'm going to sort of sketch it. There it is. Not the prettiest line, but there it is. Okay, so let's take a point, like I'm going to take the point 2, 5. 1, 2 to the right, and 1, 2, 3, 4, 5 up. And I'm going to think about how that crosses this line. It does not go down here. It has to go so that it is perpendicular to the line. That was that whole thing on our very first, let's see. This is the problem with paper. There's too much of it right here. Remember, that has to be a 90-degree angle. It has to move perpendicular to the line. So it has to be going like this way so that that makes a right angle. So I'm going to think about how far this is away from the line, like in diagonals, like one diagonal box, another diagonal box. But that's not a whole one. That's like a half a diagonal. So whole 1 plus a half, 1.5 diagonal boxes. So here's a half on the other side and then a whole. So it will end up right here. That point is at 5, 2. So let's look at what happened. None of the signs changed. What happened was that the x and the y just sort of traded places. And that's what happens. When you reflect across the line y equals x, because that's what line this is, y equals x, your coordinates just trade places. Let me do another example. Let's say we take the point -1, 3. Okay, if I take those and I trade places, then the 3 comes first and then the -1. So that would be 3, -1. And we see, does that look right? Yeah, that looks right. This is like 2 diagonal boxes on this side, and this is like 2 diagonal boxes on this side. And that makes a nice right angle. That's like a corner. And remember, anytime you're not sure if you have a right angle or a corner, you can use like the corner of a piece of paper. There's a right angle. Okay, so the rule, I don't even know where my rule sheet is now. There it is. The rule for going across the line y equals x is the x and the y that you had to begin with, just trade places. Whatever x and y you had to begin with, just trade places. And the last one we're going to talk about for a rule is if you go across that, there we go. This is that line y equals -x that I talked about. Okay, let's say the point 1, 3. Okay, that is like one diagonal, another diagonal from the line. So I'm going to go on the other side, 1, 2. And it goes right here. So let's see what that's, the coordinates at that point are -3, -1. -3, -1. So let's look at what happened. They traded places. The 3 came first now, and the 1 comes second. They also changed signs. They both changed, they traded places, and they both changed signs. Let's see if that's really the rule, if that happens for another one. Let's look at 4, -1. Okay, if we trade places, the 1 would come first. And if their signs are both opposite what they were to begin with, then the 1 is going to have to be positive, and the 4 is going to have to be negative. So 1, -4. Okay, so they traded places, and both of them are the opposite sign from how they started. Let's see if that seems to make sense. Does that look like a reflection? It does to me. Okay, so the rule, and this is the last rule we have for reflections, for across the line y equals -x, is they trade places and they both switch signs from whatever they were. If they were negative, now they're positive. If they were positive, now they're negative. Okay, so we're going to look at these, look at doing some quick practice with these. And this is why I told you you needed to make sure you had paper handy, because I'm going to have you do some practice problems. Okay, You have an assignment for this that's going to be on Delta Math, and these practice problems are specifically like the ones you're going to have on Delta Math to make sure you know how to do those before you try it. So let me move this so you can see this better.
Boy, Matthew playing with the wrong type of balls, old faggot ass nigga.
And
Gianna look like she about to kill herself.
we are gonna go to this one right here. Okay.
What did you ask?
Hey guys, stay muted. Okay. All right, try this one. This one's asking me to reflect across the x-axis. Okay, so you have to think about which rule is it to go across the x-axis. So across the x-axis. Okay, so the only thing that's going to change when I go across the x-axis is the sign of y is going to change. So I have to figure out where this point is originally. It's at -4, -3, because I go left 4 and down 3 to get there. And if the sign of y is going to change, that means just the -3 is going to turn positive. So my answer is A. Okay. Next one is reflection across the y-axis. When we reflect across the y-axis, which sign is going to change? Is it the sign of the x or the sign of the y? Across the y-axis, it's going to be the sign of the x. So it's basically the other one. If you go across the y-axis, the sign of x changes. If you go across the x-axis, it's the sign of the y that changes. Okay, so we're going to change the sign of x here. So first we have to figure out the coordinates and then change the sign of x. Okay, so I lost my screen there for a second. But on that one, it was the sign on the number 2, it was the sign of x that's going to change. And so that gave it to us as A. The answer was going to be A. Questions there? Did you guys get that okay? All righty. Let's go look at another couple. First, I got to share. Going back and forth so much, I'm losing my place. I want to make it so you could see both of these. Go ahead and try 3 and 4, and then we're going to skip to some that are different lines. Okay, on number 3, the original point is at -5, -2, because you go left 5 and down 2 to get there. So if we reflect across the x-axis, is the sign of the y that's going to change. So this is going to become positive, and that's the only change that's going to happen, which makes it B. On number 4, reflecting across the x-axis, again, that was x-axis also. This point is originally at 1, -2. It's going to be the sign of the y that changes because we're going across the x-axis means we're going up and down. So it's going to be up here. So the y sign is going to change. That's going to be positive, and it's going to be right here. Okay, let's look at one that's over a different line. Let's go across. Hang on. Gotta find an interesting one. How about this? Okay, couple of things I want to tell you about this one. One is this is a whole triangle, but when you're doing a whole triangle, that doesn't necessarily mean you really have to do all 3 points, because these answer choices might be narrowed down just when you do 1 point. The other thing is, don't try to do it as a whole figure. Anytime you're translating or rotating or reflecting or even dilating a figure, don't try to do the whole figure at once. Just do a point at a time. Okay, so for instance, I might take the point S, and S is currently at 2, -1. And then I take my rule for reflecting across y equals x. And that rule is that my point trade spots. The x and the y just trade spots. So I'm just going to take these 2 numbers and I'm going to trade spots. And when they trade, they take their sign with them. If there's not a negative in front of one of these, then you're not changing the sign. You're just putting the sign the way it was. The 1 was negative, the 2 is positive. They just pick up their suitcase with their sign in it and go to their new home. So -1, 2 is the S prime. There's only one of them that has that answer, so that must be the answer for all 3 points. Okay, and you can actually see if that kind of makes sense. If you go -1, 2, remember the line we're reflecting across is supposed to be y equals x, which is this line right here. And that does make sense that this point would go over there, across it, leap right across it. Okay, so here's another one like that. Go ahead and try number 11. If you're not sure where to start, you can really pick any point, but I would probably pick point H. It doesn't really matter, but if you pick point H and then apply the rule to it, I think you'll be able to see your answer pretty quick. Okay, so point H is currently at 1, 2, 3 to the right and up 2. I just realized you might not be able to hear me, but 3, 2. Okay, and so if we're going to reflect it across y equals x, the rule is you just trade the x and the y. So that means the 2 comes first, the 3 comes second, and that's B, because that's the only one like that. Okay, now there's one more type of problem we have to talk about that's a little bit different. And that's ones like this. It says reflection across y equals -1. So you have to know this. You have to know that vertical lines have the equation x equals some number. And I'm going to put a number symbol. And horizontal lines have the equation y equals some number. Now, if you don't remember that, and you're asked to reflect across a line and it just says y equals or x equals, then go to Desmos and type in whatever that equation is. Y equals 5, x equals 2, and see where that line is. So vertical lines means up and down, and they have equations like x equals 5. And horizontal lines are left and right, and they have equations like y equals -2. Just y equals some number. Okay, so on this example, if it says y equals -1, then I'm going to go up and down the y-axis till I get to where y is -1. And then I'm going to draw a horizontal line there because that's all the points that have a height of -1. That's basically what that means. We're going down 1, and all those points have a y value of -1. Every single point on that line. This is 0, -1. This is -1, -1, -2, -1. Every single one of those has a y value of -1. So that's the point, that's the line we're going across. Now, another important thing that happens in this one problem is we have a point that's on the line. Important thing to know is every time you have a point on your line of reflection, remember the whole idea is however far it is away from the line of reflection, it's going to stay that far away. If it's on it, it's not going anywhere. So every point that is on the line of reflection stays put. So in this case, that point, y, which is at 1, 2, down 1, so that's 2, -1, y is going to stay put. So that means my only possible answers here are B and C, because those show that y is going to stay right there. So now I know it's definitely not A or D. But now I need to think about what happens to W or X. So again, just treat it like you would almost like the x-axis, but it's not the x-axis. We're not going to use that rule, but the same idea from how we started, where we were just saying, how far is this above? How far is this below? This point, W, is 1, 2, 3 boxes above the line. So I'm going to go 1, 2, 3 boxes below the line, and this is where W will go. Now I have to remember there's the origin, not here, it's up there. So I'm going to go down. This is 0, 1, 2, 3, 4. 0, -4 is my right answer for W. That one right there. So if you are dealing with a horizontal line or a vertical line, you basically just have to count and say, however far on this side, I'm going to go the same distance on this side. Or however far below, I'm going to go the same distance above. Let's try another one like that. Oh, those are translations. That's our very last thing to look at. I'm going to change this one. This one says reflection across y equals -2. I'm going to change it. Let's call it x equals -2. I wonder if the right answer is still going to be there. Probably not. Nope, it's not. That's okay. I just want to make sure we do one that's about going across a vertical line. Remember, vertical lines are the x equals lines. And I'm going to show you guys that sheet where I wrote those things again for you to make sure you can see it. But vertical lines go up and down. And it's x equals some number. So in this case, x equals -2. I go to -2 on the x-axis, and I go up and down from there and draw my line. This is where that line is. That's the line with all the points on it have an x value of -2, like -2, 0, -2, 1, -2, 2, -2, 3. This is -2, -5, and so on. Every point on that line has an x value of -2. So to figure out where these points are going to go, I'm going to take them and figure out how far left or right they are from that line and go the other way. Okay, so right now I am 1 unit v. Let's look at v. V is 1 unit to the left of the line. So I need to go 1 unit to the right of the line. So here's where v prime will go. So v prime, the new v, will be at -1, 0. W is currently 1 unit to the right of the line. So I'm going to take it 1 unit to the left of the line. So that's where W prime will go. So W prime is at negative, here's 0, 0, 1, 2, 3, and down 2. -3, -2. And last but not least, U is over here 3 units to the left of the line. So U is going to move 3 units to the right of the line. And that puts U prime at 1, -5. So that's where my coordinates will be. And if you are asked to draw the whole picture, like to draw the triangle, you just take, I think that'll work. And now you can connect them. So you do it 1 point at a time, and then at the end, you can connect them and make the shape. You won't have that many problems like that, but I wanted you to know how to do them if you get them. All right, last thing is, I told you translations are pretty easy. Okay, here's why translations are easy. Here's what makes them easy. When you look at the rule for a translation, it tells you exactly what's supposed to happen. It tells you, okay, if you have a point X and Y, whichever point you're picking, Q or R or S, you're going to take the X value and you're going to subtract 1, and that'll be the new X value. You're going to take the Y value and you're going to subtract 3, and that's the new Y value. So for instance, Q is at 0, 1, 2, 3, 4. Q is at 0, 4. This rule for this translation, and a translation is just a slide. It's not going across a line. It's just sliding over. Says subtract 1 from the X, subtract 3 from the Y. So I'm going to do that, and I'm going to get my new Q, or Q prime, is -1, 1. And I could go ahead and I could do that with every single point. But if you look at the answer choices, this is the only one that has a Q value of -1, 1. So that must be correct. So the rule for a translation really just tells you exactly what to do to the old X and Y, to the pre-image X and Y values. Okay, so let's look at this one, number 14. How about let's all do just point R. Okay, figure out where point R is, figure out the coordinates for point R, and then go ahead and do this to point R. I will wait for you. Okay, so point R is currently at 1, 2, 3, 4 to the right and 3 down. It's at 4, -3. Okay, this tells me to to subtract 5 from the x and add 4 to the y. So I'm going to take that point and I'm going to subtract 5 from the x, which gives me -1, and add 4 to the y, which gives me +1, and that's where R goes. And the only one that shows that is B. So with translations, what you see is what you get. You do exactly what it tells you. Now, there is one other little thing to know about translations is sometimes you'll see them written just a bit differently. Instead of parentheses, and they're not brackets either, they look kind of like greater than and less than symbols. Sometimes the same information could be given to you like this. It means exactly the same thing. This tells you what to do to your x and your y. This says subtract 5 from the x, and if it's positive, that means add. That's called vector notation. So that would be another way of writing the exact same thing, asking you to subtract 5 from your x and add 4 to your y. This one over here in vector notation would look like that. Excuse me. Just means do the exact same thing. I don't know if they use vector notation on the Delta Math, but I thought they might, so I wanted to show you just to make sure. Okay, so let me give you, I got 2 more practice problems. You go ahead and do those 2, and I'm going to call on somebody for the answers. So try them. Make sure you have a good answer because I'm going to call on you. Just real quick, let me point some things out to you as you're finishing these. If we subtract from x, that means we're moving it which way? Left. And if we add to x, we're moving it right. Similarly, if we add or subtract from y, that tells us whether we're going up or down. If we add, we're going which way? Up. And if we subtract, we're going down. So if you look at number 16, another way you could interpret this is like saying left 2, because left is negative for out of left and right, and up 1, because for y, it's up and down, and up is positive. Over here, this x value is not changing, so it just stays the same. And then we're taking our y and we're going up 4. Okay, so let me go ahead, and I have to be able to see you guys to call on you, so stopping my sharing. How about Noah? Noah, what'd you get on number 15? think Noah may have checked out on us. How about, I'm going with Skylar. How about Skylar? What'd you get on number 15?
I got C, but I'm pretty sure I did something wrong. So
You could tell me in the chat if you'd rather.
I got C, but I'm pretty sure I did something wrong because it doesn't look right.
Oh, y'all, I'm so sorry. My computer was muted. I apologize. I didn't even realize I wasn't hearing you. I'm so sorry. I was like, why does it look like Skylar's talking? Skylar, which one did you get on number 15?
I got C, but I'm pretty sure I got it wrong because
You got it right.
Oh,
It is C. It is C. How about number 16? Let me ask Sean. What'd you get, Sean? How about Matilda instead? All right, Gannon, I know I've got your attention. What'd you get for number 16?
I can't find number 16. Where was that at? I was looking at number 15 and the ones before there.
Okay, 16 was on the right of number 15, but that's okay because Matilda answered in the chat. She was having trouble with her microphone. So Matilda got B. Does everybody agree with B? Me too. Okay, so you should be able to practice this on the Delta Math. It's called Translations and Reflections. So go to the Delta Math called Translations and Reflections and practice that. And then tomorrow we'll do more practice of all of this. And this is what's on your quiz. It's transformations in general, and then reflections and translations.
So
Okay.
practice on Delta Math.
Practice on Delta Math is what you have left, and that's it for today.
I have a question.
Yes.
I don't know how to do that.
How to get on Delta Math?
Yeah, no, because I have like an account for Delta Math, but I don't.
Yeah, okay. If you are not on Delta Math, stick around for a few minutes. If you have trouble getting on Delta Math, you guys stick around and the rest of the people can leave. Okay, so if you're having trouble getting on Delta Math, the place I told you, where I told you, if you were wondering if you missed something, is on the Nearpod you did for Thursday's assignment. The last slide was a little video I made walking you through how to get on Delta Math. And it had my teacher code in there. If you are already registered for Delta Math, you don't have to like make a new account. You could just use the teacher code to add yourself to my class.
How?
If you, okay, but let me show you what that code is. Hang on. If you need to make an account, then I might watch the whole video just to make sure I understood where to go and what to get. But this is my teacher code. Can y'all see it okay? It's 120705.
But
So
when
that should get you in.
I have an account for Delta, but it was still logged in for like my last year's class, so I couldn't.
Okay.
I didn't
Yeah,
know
that
how to,
can make
like,
it
add that.
complicated. Okay, let me know if that doesn't work. If there's if you still have a problem, let me know, okay?
Okay, thank you.
Okay, thank you, Tana.
Bye.
Bye.